All right, so what we're going to do is delve into the world of measuring angles with radians. And why do we even do it? Well, it turns out that measuring with degrees, it's kind of a contrived system. We just made it convenient, and that, circles being 360 degrees, it's arbitrary, really. Like, who made up this number? There's really no rhyme or reason to it. Well, there is some rhyme and reason to it. It's just that it's not relevant to us. So, looking at a circle again, so we're going to define a radian to have a direct effect on how long the length of the circular arc is. And as you notice in the picture here, 1 radian is the angle, and this angle right here is what I'm talking about. That's the central angle. It's a central angle required so that the length of the arc is the same as the radius of the circle. Okay? So, definition 1, theta is that central angle right there, and that is the definition of 1 radian. So looking at a couple pictures here we have a circle whose radius is r, and that length right there is 1 radian, which means the length is r. So the length of the arc is 1r. If I go 2 radians, notice that the length is going to be 2r. So that quickly gets us to this formula that, if I call s the length of the circular arc, s is equal to r theta. Definitely know that formula. That's going to be so important as we move forward with a lot of things here. So now let's think about what we already know about a circle. We already know that the circumference of a circle, or one full trip around the circle, is 2 pi r. We know that that's the circumference of the circle. So noticing that that is the entire thing, that's some multiple of r, it does relate to a central angle that corresponds to 360 degrees. And I know I'm not hiding the surprise at the bottom of the screen here, but at least it tells us what is happening here. So that means that 2 pi radians is the same as 360 degrees. So we have ourselves a conversion factor here. If 2 pi radians is 360 degrees, if I divide both sides by 2, that means pi radians is 180 degrees. Which means 1 radian, if I do a little bit of division here, divide both sides by pi, is 180 divided by pi degrees. Which means 1 degree is pi over 180 radians, just dividing both sides by 180. Now what that means also is that 1 radian is approximately, well, let's see. If I just take 180 and divide by pi, 1 radian is about 57.3 degrees. I'm just going to round that to the nearest tenth because that just seems sufficient. Okay, so this is our new way of measuring angles. And you're probably wondering, why do we do it? Well, let's just get to conversions first, and then we'll talk about more. So 50 degrees. Well, I know that every degree is pi over 180 radians. So if I just simplify that, that gives me 5 pi over 18. So many of these angles are going to have nice radian measures. 240, same kind of thing. If I multiply by pi over 180, 60 goes into both 240 and 180, I get 4 pi over 3. All right. Now, notice when we talk about radians, the label's not really required. I'm just writing it here for effect, okay? Radians are actual numbers. They actually represent units, okay? They have an innate relationship to the length of an arc. So I always say include it even if you don't have to, just so everybody knows that you're talking about radians. We use the degree symbol no matter what when we're talking about degrees, okay? So let's just convert radians to degrees. Now we know that 1 radian is 180 over pi degrees. So if I'm going from radians to degrees, I'm going to multiply by 180 over pi. So let's just see what we have here. 2.5 times 180 over pi. And yeah, that's approximate. We have negative pi times 180 over pi. And what you probably realize that the pi's cross out. We have 0.25 times 180 over pi. So if I round each of those to the nearest tenth, we have 143.2. We have negative 180 degrees, and we have 14.3 degrees. Okay? And one last thing before we stop our introduction to radians is let's look at some special angles that we've already encountered, okay? And remember that all we have to do is multiply each one of these by pi over 180. Because remember that every degree is pi over 180 radians. So if I multiply all of these angle measures by pi over 180, this will give us pi over 6, pi over 4, pi over 3, pi over 2, pi, 3 pi over 2, and 2 pi. And there's many more in between, but that is our short list for now, angles to watch out for, because again, since 30, 45, 60, etc., were all special angles, we need to learn their radian counterpart. So that's where we'll stop for now, and then we'll pick up where, as you see, complements and supplements and some other things we can do with radians.